Max height. Now, you guys have learned a few different things about maximum heights in physics. When can we find the maximum height of a projectile? The gradient is 0? What do you mean by that exactly? When it's at the top. Okay, so the gradient at that particular point, maybe? Like the tangent or something?
When the y component would be 0.
So let's just draw the graph out first. So let's say this is our ball going up. And you're saying at this point here, at the max height, you're saying that like a tangent, if you drew a tangent out, that would be 0? Is that what you're saying?
Yeah.
And what were you saying?
And the y component would be 0.
The y component is 0?
Of v. So like v dot.
Ah, okay. So the y component of the velocity is what you're saying should be 0. Sorry. Of v, yeah, good. So, yeah, no, that's because the y component will have a value, right, for the displacement. It'll be like the maximum height. You're both right. So, in projectile motion, we consider the horizontal and vertical components separately, right? So, at every point in time, like there is going to be a horizontal and vertical component. But as you kind of get higher up and higher up, like there's a certain point here where no longer, yeah, right, because no longer is it increasing or is it decreasing. It's literally going to be 0. And that's what we can use here. Another fact you might want to use is, hey, this is actually a parabola, right? It's following parabolic motion. So think about what we've been doing in 2 unit with, yeah, right, with kind of like maximums of parabolas or kind of any function. The maximum also occurs halfway between the 2 endpoints. So it's just like another option that you have, right? So the max height, either look for y dot equal to 0. Assuming that's true. That's it. Yeah, you have to make sure that's happening. Yeah. Or what did I say? Halfway.
Yeah, I think that's what we did.
Between the endpoints.
Basically, we did find y equal to 0.
Yeah.
Sometimes we used to find t in half t.
Yeah. So if you find the range of flight.
Well, we would do either way.
Yeah. So if a situation like this, you could, for example, if the question asked you and you found the range of flight, time of flight. Then you can just take half of that, and that's when the maximum would occur, and you could sub it back in, right? So basically, once you have the equations are going to involve by using them to solve these. So go to your velocity one. Which one's the y component? So here's our velocity equation. So what's the y component really asking for? Well, I know something should be equal to 0. The j, yeah, the j. Well, this is your vertical, right? So here, we'll let negative 9.8t plus 18 sine 35 degrees equal to 0. Okay, what am I solving for here? Well, remember, I want to find the maximum height, but right now this is in terms of t, right? So let's go ahead and solve that. When I do solve that, I'm going to have to do something else. What else will I have to do? Because what am I finding here when I solve for t? What am I actually doing? So this is, yeah, that's exactly right, Jay. So for when max height occurs, so again, communicate what you're doing. For when max height occurs, let 9.8t plus 18 sine 35 equal to 0. And then we can go ahead and solve that.
Yeah, this doesn't work.
So we get 1.0.
Wait, do you have radian?
I do in fact have radian.
Classic mistakes, yeah. Sorry.
Yeah,
so,
I got 1 point.
Yeah, so you gotta be careful because we're kind of working with radians and calculus, and then whenever you do projectile motion, you gotta switch back to degrees. So sorry, it's all over the place at the moment. What did you get, Callum? 1.0.
1.0535.
Yeah, cool. At this point, I guess we don't want to round because you still want to use this value, yeah? So don't round at this point. But like, let's do what James said. What we want to do is now we want to go to our displacement. Sorry? Well, we're not using it yet, but I'll put seconds for you. It's not a final answer because we're asked to find the max height.
It's nice to put.
Okay, just for you, man. So once you have this, right, what do? We'll put it back in here as t, but hang on, I'm looking for the maximum height. So we're really only interested in the y component. You could put it back into the x component. I guess that would just give you how far it is at this point. But remember, you've got to read the question carefully, what you're actually trying to do, right? So for this one, what we want to do is say at t equals to 1.0535, right, and we want to substitute it into here. So our displacement, so we should add t equals to this, the y component, so I should say, the y component of S. So that's going to be this part here. We'll say that's equal to, I'm going to say that y is equal to negative 9.8 times this guy all squared. So if you haven't already, you should probably store that in your calculator rather than just rounding it.
Supposed to know how to small things on calculator.
I mean, if you should use that as an answer and then press
Or just like.
There's a proper way to do it. Do you want me to show you?
Is it like
Not right now.
Yeah,
It'll be
okay,
too
sure.
much, but
I'll show you later, yeah.
one day.
But yeah, you can just use the answer key for now. What was it? 5.4.
So you have your answer, you press shift.
Can you guys just check that we all got that?
Then you press
Let's round it to 2 dp, so 5.44.
AT and press equals.
Alright, we're dealing with meters, aren't we? Yeah.
A little later. No, I don't even know how to do it right now. I think I have
So he's already made his case.
I don't want to know.
Sorry.
5.44.
I don't want to know.